Okay, so, so I'm doing the question on paper 2, time zone 1, and the table below shows the the distribution of the test grade for 50 students, IB students at Greendale School. Anyways, this is a chart and the mean test grade of the students. Okay, the way to figure that out is you can go on a calculator. You can press that, edit, and here basically you list all the numbers, which I did already in this one. And then you press stat again, and you press calc, and you do 1. And since you already have the L2 inserted, which is this line, you don't need to change that or anything, so you go to calculate. And here they give you the mean, and the mean is the first one right here. So it's 4.6. The standard deviation will be right here, and that will be 1.45. But we're gonna round it up, so
6.
So it will be 1.46 because it's higher than 5. Find the median test grade of the students. So here you just go down, and it says right there the median, and it's 5 equals to 5. So the answer is 5. And it says find the interquartile range, and to find that is Q3 minus Q1. And if you go down, Q3 is 6 minus Q1, which is 4, and that will give you 2. To continue, a student is chosen at random from these 50 students. So we got 50 students here. Find the probability that the student scored a grade 5 or higher. So here we're only focusing at a test grade at 5 and higher, so these 3. And we know that it's out of 50 students. So basically we add 11 plus 10 plus 5, and that will equal 26. And if you put that in a calculator, 50, that will give you 0.52%. For D, the second student is chosen at a random from 50, so still 50 students. Given that the first student chosen at random scored a grade 5 or higher, find the probability that both students scored a grade 6. So here we already know this one, which is 26 out of 50. They want to know the probability of the students that scored a grade 6, so just this part. And so out of 26, only 10 of them had a test grade of 6. So you put that in a calculator. Out of 26, that would be 38%, 0.38%. The number of minutes that the 50 students spent preparing for the test was normally distributed with a mean of 105 minutes and standard deviation of 20 minutes. So we got that 105, so that's important. Calculate the probability that a student chosen at random spent at least 90 minutes preparing for the test. So here we can go back to, we'll go to second bars, and you press number 2, and here you're going to clear that. So the lowest is 90 minutes. You go down, it will be 1 second infinity to the negative 99. Here we're going to put, which is 105, which is a mean. Here we're going to put the standard deviation, which is 20, and you press paste, enter again. So the answer is going to be 0.773 to 3 significant figures. calculate the expected number of students that spend at least 90 minutes preparing for the test. So here we already have the expected number. All we have to do is we use that number and we multiply it by 50 students, which will give us 50, which would be 38.73 significant figures. And that would be the number, the expected number of students. So yeah, that's how you do it.